Hello and welcome to my channel. In this series I take you through past VCAA Maths Methods exam questions and provide you with my full work solutions. In today's video we're going through question 7 from the 2020 exam 1, so that's the Calc 3 exam. As always, I invite you guys to attempt this question first before watching me do it, and you'll find the link in the video description as usual. So question 7, it's worth 8 marks, starts off by saying consider the function f of x is equal to x squared plus 3x plus 5 at the point P 1, 0. Part of the graph is shown below, and part A says show that the point P is not on the graph of y is equal to f of x. Okay, so we've got this function that's a quadratic. They're showing us part of it. We know this point here should be 5, since that's sort of it's in that standard quadratic notation where 5 would be that y-intercept. And we've got this random point, or seemingly random, because it's at coordinates 1 and 0. So that's an x value of 1 and a y value of 0, meaning it's on the x-axis. So it's obviously not on the line if we were just to draw it. There's no scale in the x or y direction, but it'd be, roughly here, doesn't matter, just for illustration purposes. So part A says show that the point is not on the graph. So how do we show that it's not on the graph? Well, the easiest way that I can think of, there's a couple of different ways. The easiest way would just be to sub in the x value of coordinate P, and then we check to see if the y value matches. So if I just zoom in a little bit, so I'll say sub x is equal to 1. So we'll have f of 1 is equal to 1 squared plus 3 times 1 plus 5. So 1 plus 3 plus 5 is equal to 9. And that does not equal to 0, does it? So we can conclude, therefore, that point P is not on graph y is equal to f of x. Since it's a show that question, sort of got to state a few of these things. Hopefully, I think that should be clear enough for 1 mark. Cool, so question B, consider another point, Q now, at x is equal to a, and the y value is on that line, so f of a to be a point on the function f. Find the slope of the line connecting Q, P and Q in terms of a. So another generic point, point Q, a, and f of a, if I were just to draw that on somewhere. Now I've just picked a random spot. Since it's all in terms of a, Q could be to the left of it, or it could be to the right, depends on that value of a, which we don't yet know. So it's just a point that's on this function f of x. That's all we know so far. B says find the slope of the line. So we want the slope, or the gradient, between P and Q. Well, we've got 2 points and 2 sets of coordinates, so we can just use the equation for the gradient that uses 2 sets of points. y2 minus y1 over x2 minus x1. And if I just call this, Q can be 0.2, P can be 0.1. So this is x2, y2, and then P, I guess P, if I draw it over here, is x1, y1. Sub in those points, and what will we get? We'll get f of a minus 0 over a minus 1. And f of a isn't yet just in terms of a, so we'll need to evaluate the function at point A. So if we were to sub in a here, we get a squared plus 3a plus 5. So we have a squared plus 3a plus 5 is equal to a minus 1. Great. So that is the gradient in terms of a. Hopefully that's nice and clear so far. Next part, BII. Find the slope of the tangent to the graph of f at point Q in terms of a. So now we want the tangent. Previous part was the slope of between 2 points. Now this is only reliant on point Q. It has nothing to do with point P. So depending obviously where point Q is, we'll get a different value for the gradient of the tangent. If I was to sort of, where I had Q previously, that would be the tangent roughly there. But obviously it depends on where point Q is. If point Q is over here, then the tangent will look something like that, for example. Hopefully you sort of get the idea. It depends on where point Q is. But in general, depends on the function. So for tangents, we know we can find that using the derivative at a particular point. So gradient of the tangent will be equal to the derivative at the x value. So the derivative of our function would be 2x plus 3. Since it's a polynomial, nice and easy to find the derivative of that, 2x plus 3, but it's at the x value that x is equal to a, since we're at a long point cube. So instead of being 2x plus 3, it's 2a plus 3. I haven't really done, I would probably do a couple more lines of working to make that a bit more clear. You can see I'm obviously skipping a couple steps here, but since it's only worth 1 mark, it's probably obvious enough, and I've met the main criteria there. But definitely would encourage you guys to do more workings, sort of use the number of lines as an illustration. But just for time in this video, I'll leave it at that. Great, so parts I. Let the tangent to the graph of f at x is equal to a pass through the points P. Find the values of a. Okay, so this, you might have to think about this a little bit, and you may need to read the question a couple of times and try to visualize what's going on here. So how I understand this, it says let the tangent to the graph at the point x is equal to a, so that's at Q, pass through the point P. So now we want essentially what it's saying is we want a tangent, but we want the tangent to pass through point P. So essentially, there's 2 ways that we could achieve that. So first one, maybe if we had the tangent at point approximately over here, you could see if we shift that, it should be a tangent and it should pass through point P. That would be one solution, and the other solution would be over here. You can roughly see if we took a tangent at that point there, it also passed through point P. So we should be expecting 2 solutions. And it's good just to build up your intuition and your understanding of the question before you start answering it. So what does that mean? So this is the instantaneous rate of change, or the gradient, because it's the tangent, but it's also now the average rate of change, or the what we used in BI, the slope between the 2 points. So at this criteria, and I'm lagging a little bit. So essentially what that means for part I is this gradient here will be equal to this gradient. The gradient for the tangent is equal to the gradient of the slope between points P and Q. So we just need to equate both of those together. So what we've got the gradient is equal to the gradient of the tangent, which was equal to a squared plus 3a plus 5 on a minus 1, which was equal to our other answer of 2a plus 3. Multiply the a minus 1 to both sides, we'll have a squared plus 3a plus 5 is equal to 2a plus 3, a minus 1. Expand out the right hand side, I'll leave the left hand side the same in this step. We'll have 2a squared plus 3a minus 2a is, I think it should be just plus a minus 3. Have I done that right so far? I think so. Next, going to take everything over to the one side, and we'll have 0 on the other side. So if I subtract from the left hand side everything, we'll have a squared, a minus 3a is minus 2a squared, we have minus 3 minus 5 is minus 8. Then hopefully you guys are able to factorize that nice and straightforward. This one, a minus 4, a plus 2. So just looking for the different factors of minus 8, so minus 4 and 2, or 4 and 2 are the most obvious, or 8 and 1, but we need to add up to minus 2, so it's minus 4. And positive 2 in the brackets, which makes our answers for a equal to a is equal to minus 2, or a is equal to positive 4 as the 2 solutions 4a. There we go. Something like that. That snap there. Cool. So we've found the values of a. There's two of them. Part IV. Give the equation of one of the lines passing through point P that is tangent to the graph. So remember, point A was the x value of the coordinate Q. So in other words, we've now found that x value and we're using it to work out what the actual tangent would be, not in terms of A. So we found A, taking it, substituting it back into the equation of the tangent that we had previously. So it should work whether we substitute it into this form or this form. This one's clearly the easier one to choose. So I'm going to use that and sub in the positive value of A because I think it's a little bit easier dealing with positive numbers. So we've got the gradient of the tangent is equal to 2a plus 3, where a is equal to 4. So therefore the gradient of the tangent is equal to 8 plus 3 is 11. So far we know y is equal to 11x plus c, just using the y is equal to mx plus c standard form. Next we have to work out c. To work out c we need to know a full coordinate that passes through, which is the equivalent of point Q. We know the Q was equal to a f of a, so therefore Q of 4 would be equal to f of 4. So if we sub in 4 into the original function, we'll have 4 squared, which is 16, plus 3 times 4, 12. So 16 and 12 is 28, plus 5 is 33. So now we know, sorry, it's a little bit slow today. Now we know this point here is 433. Using that point, we can finish it off, work out the value of c, and we'll have the gradient of the tangent. So subbing in the point, 33 is equal to 11 times 4. 44 is equal, plus c. Therefore, c is equal to minus 11. So therefore, the gradient of the equation of the tangent, so y of t, is equal to 11x minus 11, like that. Great. Last part, part C. Find the value of k that gives the shortest possible distance between the graph of the function of y is equal to f of x minus k and point P. So we want the smallest distance between P and a translation of k units to the right and P. So really important to understand the translation that's going on here. The fact it's going right by k units. Now if we go back, so we've got the line in black is the equation that we're interested in, and we want to shift everything by k units, right? So these arrows are a bit average. You get the idea, everything's going k units to the right. So how can we possibly make the distance between this equation after it's been translated and the point P a minimum? Well, if you've got a strong understanding of what the question is saying, it should be hopefully a little bit clear at least that if we translated the minimum value of this function, so the turning point, and we shifted it just enough so the turning point was right above point P, that would be the smallest, that would give us the smallest possible distance between a translated version of this function and point P. So it would look something like, after it's been translated, something like that, right? So this distance here is a minimum. We want that distance to be a minimum. Cool. So what would be useful is to first work out, I guess this is the real key, is working out what is that point originally. So we can figure out what it needs to become. It needs to become an x value of 1. And that the difference there will be that value k that we need to translate it by. So to work out the minimum, we could let the derivative of the function f equal to 0. So let's say for min, let the derivative f dash of x equal to 0. And we know that the derivative function f dash of x is equal to 2x plus 3. Let that equal to 0. So therefore the x value is minus 3 on 2. Minus 3 on 2. Great, so we know the x-coordinate is minus 3 on 2. We don't even need to work out the y-coordinate, right? Because it's a minimum either way. It's got a positive value, but the only thing that matters is how far we're shifting it across by. So currently it's minus 3 on 2, but it needs to become vertical or directly above point P, which has a value of 1. So we have to translate 3.5 units to get to having a minimum on the y-axis and an additional unit to have it directly above point P. So 3.5 plus 1. So 5 on 2 units, right, is what we need to translate by. So if I just sort of finish off my workings, I could say k is equal to 5 on 2. Put that in the box. But maybe I want to say at this line, therefore we must translate the function f of x by 5 on 2 units. Right. Something like that, just so it's nice and clear what we're doing there. And I think by also sort of overlaying with some annotations, that makes it clear as well. We obviously don't want to make this graph too crowded, especially if we were asked in any of the questions to draw something specifically, but because this one didn't actually ask us to sketch anything additionally on the same Cartesian plane, we can sort of annotate that as freely as we want. I might just get rid of that line in my workings. Great. Okay, so that's question 7 done. Let's have a quick look at the examiner's report and run back through. So question A here was answered pretty well, 85% getting the mark. Some of the notes from the examiners read, some students would just simply do the substitution, but they didn't explain the relevance, so they didn't get the mark. So that would sort of suck, right? If you do this step, but you don't state that point P is not on the graph. So you sort of do need to include this sentence here. Other students use the discriminant and found that to be negative. However, they didn't sort of relate it to the question. So it's really important to sort of make it clear. And sometimes the easiest or the best thing you can do is just include a short sentence. Moving on to BI. So had 52% get this correct. Many students wrote down an expression for the gradient, but went no further. So some students might either have done this step or this step, but they didn't evaluate it. So it's really important to have it all in terms of A, not in terms of this function of A. So that's, easy marks that a lot of students missed out on, unfortunately. Or some students cancelled out or tried to cancel out A, but did so incorrectly. Part II, 67% answered correctly. Most students recognised that the derivative was required. Some students incorrectly assumed that the question required the equation to the tangent at x is equal to A. Yes, answered pretty well. Moving on to the last couple parts. BII, we had 31% get full marks, 14% get 1 mark, and 56, so more than half, didn't get any marks on this one. So students sort of struggled to draw the conclusion, I think, between the two equations and how they tied in. So it's sort of, I think, really beneficial to annotate the graph and try and see the connection where you can. Students who equated gradients tended to score more highly, so that was sort of the key to that question. BI, VI, BIB. The most common error was students assuming that their value of A was the gradient of the line instead of substituting it into the equation. So sort of it talks at this point here, they thought A was the gradient, but no. As we saw in the previous part, that's the components, and then we need to substitute a is equal to 4 into that. This here is the grading of the tangent. Only 30% getting to that point. I think a lot of people, once you start losing some marks, they probably don't have strong enough understanding to get marks in the previous questions. Not that they're particularly hard, but I think if you sort of start getting confused, then it's really hard to sort of figure out what to do from there. But yeah, that's why methods is so important to have strong comprehension skills and analytical to sort of problem solve your way through it and relate the theory that you do know that's not too difficult with more abstract sort of questions like this. Quite a bit more problem solving. So last question C, find the value of K that gives the shortest distance. So only 10% of the students got 4 marks for this one, and only 3 got partial marks. So you can see, close to 90% got 0 for this one. And the solution sort of talks through, all the notes talk through that they take the same approach. They find out what the minimum is beforehand, and therefore sort of note that it needs to be translated. So many students use the distance formula and then attempted to differentiate and equate to 0, often with limited success. I think that way would be doable, but obviously not the easiest way. It's much easier if you can understand it. You just need to shift everything right, and it's sort of the way that the question's set up. That should be quite obvious. That K is just a translation left and right. So students who use a geometric approach tend to score more highly. Okay, there you go. So second last question of the 2020 exam 1. Stay tuned next week and I'll provide the solution for the last question, question 8. Thanks for watching, guys. If you found something, if you found this video useful, then please give it a thumbs up and share it with friends or classmates. If you're new to the channel, then please feel free to subscribe for more content like this in the future. Lastly, if you've got any questions that you want me to answer on the channel, then please send me an email at yourmathquestions@gmail.com. Thanks, guys, and I'll see you in the next one.